Welcome to the Oracle CloudWorld presentation for Under the Covers of Oracle Real Application Cluster Deployments. My name is Sebastian Solbach. I work together with my colleague Arnie Nair in the Maximum Availability Architecture Product Management. And we do deal with Real Application Cluster as well as with high availability databases running in Oracle Cloud Infrastructure, which is especially my part. So what we will be covering today. So first of all, we will have a look at what is really new with Oracle Real Application Cluster 23C. What new capabilities you will get for your deployments, let it be on-premise or let it be in the cloud. Then we will have a look at how you can deploy Real Application Cluster databases, what deployment choices you have, either on-premise or if you want to run the Real Application Cluster in the cloud, what choices you have there. And last but not least, we will have a few look at the best practices regarding the new capabilities, what you should be looking out for, and what you essentially should be doing. If you can join us live on the Oracle CloudWorld itself, we will also have a part of a customer presentation, but which is removed from this recording. So let's have a first look at what is new in Oracle Real Application Cluster 23C. So 23C is an ongoing improvement to the existing technologies which Oracle Real Application Cluster is based off. So it's not totally new, and all the capabilities which we have included into the Real Application Cluster is really based on customer feedback. So please continue to provide us with enhancement requests or feature requests to improve your experience with the Real Application Cluster, even though sometimes it takes a little while until we implement something. Most capabilities which you see on the slide really have been introduced because customers was asking for that. Real Application Cluster is the perfect platform for you to consolidate all your applications which are running on an Oracle database into a high availability platform. And it really doesn't matter if it's a graph database, if it's a JSON database, or if it's an OLTP database. Essentially, you can consolidate your workload into a single database. And when you use Real Application Cluster, you can ensure that we are running with 24/7 without any issues. Now, when you run the databases within a single container database, we do provide the capabilities to allow you with 23C the first time to define a rank and an importance. This was really missing in 19C, where you could essentially run multiple PDBs in a single container, but there was no real management of what databases should be started first, which are important for you. The other capabilities we introduced with 23C is essentially to have faster access to the applications, and especially on planned maintenance events, so that we do allow you to manage your Real Application Cluster and have the least amount of brownout for your application. And last but not least, there is a lot to do with load balancing, how we can ensure that we are running on a least loaded node, or we consolidate the workload onto a single node to have the best performance possible. This is essentially what 23C is providing you. And now let's look at the details on how this all is working. So while already with 19C, you had the capabilities of having PDB resource management, there was no capability upfront to decide how the PDBs will be placed within a Real Application Cluster. So as you sure know that pluggable databases can only be opened on a single node, providing you with a single instance experience, even though you still get the high availability advantages of a Real Application Cluster. In 19C, you didn't have a capability to define that this pluggable database is more important and should be running on 2 nodes or 3 nodes at a maximum. Now, this is something 23C provides you, and it also provides you with the capability to assign an importance. So if your PDB is more important than another, then the cluster will ensure that this specific PDB will continue to run no matter what is happening. We also extended the definition of services, which we will look later in the best practice section, from having singleton services running only on a single node to uniform running on all nodes, which was always possible, but now also have something which we call a duplex service, which is only running on 2 nodes, no matter how big your cluster will be. So let's first look at the deployment choices or the placement choices you essentially have when starting pluggable database. So let's assume a 3-node cluster. Now you can decide to essentially use what we call fill. So whenever you start a PDB, we do ensure that the PDB will be placed to fill up a node. So the first PDB will be started on the first node. The second PDB, if it's still fitting within the resources of your instance, we will add it simply to the same node. And only if your capacity is full, capacity in this case means CPU assignment, then the third PDB will be started on the second node and so forth. So your cluster will be filled one node by the other until the cluster is full and you essentially need to add nodes. This placement policy is ideal if you know upfront how much CPUs the pluggable databases will require and will have, and you are not very volatile. Though you still can scale. However, what might happen if you require more CPUs for the RAC PDB, for example, then you suddenly might starting the additional PDBs on a secondary node, extending the cluster to a 2-node cluster, so to speak, instead of having a singleton PDB. But as I said, this really is ideal to fill up your clusterware instances to the maximum capacity. The second deployment choice is spread. So while fill tried to fill up one node after each other, spread is exactly the opposite. So we will essentially start the first PDB still on the first node, because where otherwise should we place them, and we will be starting the second PDB on the second node and the third PDB on the third node and so forth. So only when all nodes are full, we will start adding load to the additional instances. This configuration is very good if you cannot know upfront how many CPUs you will have, because when you now have to grow the CPUs of a pluggable database, we do ensure that you are scaling within the node and not across nodes, keeping all the workload on a single node. As you might remember, if you heard other real application cluster presentations, there are always 3 instances involved in a block exchange, which is the resource director, which is maintaining the block, the requester, and the master. And as long as you can keep them all 3 together on a single node, this does provide advantages in performance, which essentially is here when you have the spread and the PDU placement assigned. So the other capability we introduced was ranking. So with 23C, you now can tell us how important each PDBs are for us. So in this case, let's assume a customer where the sales database is really important, whereas payroll is less important and accounting the least. So now you can define how important they are, and you can define CPU assignment to them. So the cluster now knows how important the sales database is for you and will try to keep the sales database running whatever is happening. You can even do over provisioning with this in specifying the minimum CPUs as a fraction. So the easiest way to explain this is to look at an example. So now let's take a 4-node cluster with 8 CPUs each, and then let's look at our databases. So the first thing the ranking decides is in which order the databases will be started. So because your sales database is the most important one, yes, it started on the first node. Then payroll is the second, because we do not have 8 CPUs available on the second node and we use spread, we essentially are placed on the second. And just for the sake of visibility, let's assume that the accounting database was started on the 4th node, to essentially see what is happening. Now, let's assume the first failure scenario. So let's assume the database node where the accounting application run is essentially dying. So in that case, it's pretty easy because we still have a spare node. What is happening is that that single PDB is essentially moved to the surviving node. Now, let's assume a second failure scenario where your second instance goes down. In this case, the database running with the accounting database. as the accounting database is not that important in your ranking, and let's assume we do not have sufficient free CPUs on the sales database we will simply be shutting down the accounting database. You might know this kind of management of pluggable database, which it seems to be familiar with what we had in the previous days with what we call policy managed databases. And this essentially is the combination of it. And last but not least, if your sales database is the most important, and if the node goes down where your sales database is running, we will be shutting down the payroll database and ensure that your sales database is running on the last surviving node because it's the most important for you. What we also enhanced in the same case with the failure handling is essentially what we call the last node standing. So in case your database node would lose access to all the other nodes, but we already know, because all other 3 nodes already failed, this really is the last node, we do not require anymore that there is access to the interconnect or the voting disk. We only need access to the data disk because your database should still be running. So we do ensure that whatever happens, the last node is continue to run and to provide your most important workload to you, no matter what is happening within the cluster. As soon as the network and storage X connectivity for the voting disk is reestablished, we essentially are going back into the cluster mode, running with all nodes. So that is really important to know with the PDB placement and the enhancement that we do ensure that the last node will be always high. Another capability we introduced is what we call smooth reconfiguration with 23C. When you had planned maintenance in the past, what essentially was happening that if you shut down a node, we essentially had something like a disaster. So everything what the director of a node was doing had to be recovered by the node after the shutdown, which essentially extended the timeout for your application, so what we call the application brownout a little bit. So what we changed in 23C is the way essentially planned maintenance is working. So when we look at the resource directors, which are managing the blocks and the consoles, then what essentially happens when we now shut down a node, we will ensure that before the node is shut down, the resource director essentially gets remastered to the other node already. So we will be moving all the nodes to 19C introduced recovery buddy. So the instance already knows that he has to take over the resource director from the primary instance, but that will be happening before the instance shutdown during the drain timeout, essentially granting you less timeout for your application. And only at the end, the database is then shut down. So last but not least, we do have the applications which need to connect. And if you do have a service which is running across all nodes, you want to ensure that the connections are landing on the node which provides the best performance for you. While we had in the past already 2 connection mechanisms, which was connection load balancing, which essentially distributed the sessions or the connections equally amongst the node for a service if it was running in uniform mode. With runtime load balancing, we already introduced the capability to ensure that your database workload was starting on a node which had the least amount to do. So for example, when you had an RMAN job running on one node, we essentially did take that node out because we knew that was heavily loaded and was trying to use the other 2 nodes. Now with 23C, we introduce a new capability which is quite important for applications which normally would lead to contentions. So if you do have an application which is updating a single table and a single block for multiple nodes, you want to ensure that these updates are happening essentially on a single node, because that will increase your performance. And that essentially is what smart connection rebalancing is doing. We are analyzing the workload which is hitting the real application cluster. And when we do recognize that it's very common for specific sessions to only update a single table, we ensure that we are redirecting the sessions to a single instance. ensuring that we do not need to ship the block to the other instance, causing resource contention. So while we have talked about the capabilities coming with 23C, let's get to where do you get real application cluster and what deployment choices you have, and essentially have a little bit look under the cover, especially on the cloud services where the technologies of real application clusters are used. So first of all, yes, you can install real application cluster on premises, where you can decide to build it all yourself, which definitely has the advantage that you can choose the operating system, you can choose how many nodes you want to have, and how much shared storage you essentially want to use. We also provide the capability to deploy real application cluster in Docker images, which was a big announcement last year. However, a drawback of the manual installation, and anyone who ever installed a real application cluster knows that it's not the cluster which is difficult to install, but it's very time-consuming to prepare the underlying hardware and infrastructure to support a real application cluster. And that was the most difficult part. That's the reason we did come up with engineered systems, which does make the whole process more easier for you. And there's a small brother, so to speak, which really does make the real application cluster installation very fast and simple, which is the Oracle Database Appliance, high availability. Though it has a quite limited capacity because it's only 2 nodes with 64 CPUs and only 160 terabyte of usable storage. So if you really need an environment which can run the biggest databases, really performant, no matter if it's OLTP, data warehouse, or whatever you can think of as database applications, then Exadata is the ideal choice for you, where you can not only run a single rack, but essentially can scale up to 8 racks or even more, and you get an incredible amount of raw storage for your database and the latest technology for pman and flash. And if you look at the real application cluster technologies I introduced in the first slide, in the history slide, you might have seen that there are a few technologies that had to do with the Exadata, like the RDMA enhancement, that we essentially can avoid even block contention on an Exadata platform by directly accessing the remote memory. Now, if you do want to run real application cluster in the cloud, then your only choice is the Oracle Cloud Infrastructure. There you have 2 choices. You can either choose co-managed systems, where you do get full root access. So it's like a server on premise, and we only provide a few additional capabilities for you to make life easier, which is essentially deployment, patching, data guard setup, and so forth, to make it really easier for you. But you still have the full control over your databases, over the pluggable databases you want to administer. You do have the choice of either choosing an Oracle-based database service, which provides you with a 2-node rack system. And however, we try to ensure that whatever is happening in OCI, your system is running. So for example, we do ensure that both nodes of the real application cluster for the base database service are deployed in different fault domains, and every planned maintenance you do is always done in a rolling fashion, ensuring you that one node is always running. We also do provide the Exadata database service on dedicated infrastructure, which essentially is the Exadata in the cloud for you, which does provide immensely scaled up to 32 nodes, up to 4 petabyte of storage. And we do not require the fault domain concept because the redundancy is built into your Exadata, ensuring that it's always running. You get the same capability of cloud, the nice licensing model of only paying for what you really use also on premise, which is called Oracle Exadata Database Service on Cloud at Customer, though that is a little bit smaller. And as you see, the CPUs are also different. So in cloud, we already are using the AMD CPUs, whereas the X9 on premise is still using the Intel CPUs for the compute nodes of your Exadata rack. However, one advantages you have on the Exadata Cloud at Customers is we do provide VM node subsetting, allowing you to essentially carve up your Exadata into smaller pieces, which we don't yet have in Exadata Database Cloud Service on dedicated infrastructure. Though if you do view other presentations from the Oracle CloudWorld, I'm sure you will find an announcement that this is also coming soon to the Exadata Database Cloud Service. So last but not least, we also have the Autonomous Database. And also Autonomous Database is built on Oracle Real Application Cluster. So it's always running under the cover. And in shared, you do get up to 128 OCPUs and terabyte of storage. Though, let's be honest, that is just a restriction posed in the UI. If you do have more workload and more requirements, then we can provide more CPUs and more storage to you. There's no need to go to dedicated for this. If you go to dedicated, it's more that, yes, on a shared infrastructure, your autonomous database is sharing the same storage as other autonomous databases. And if you really want to be on your dedicated hardware, which also gives you a little bit more control over the patching cycle when we patch, then you want to have autonomous dedicated. And also there, we do use a real application cluster with today up to 8 nodes with the same capabilities as the Exadata Cloud Service. So last but not least, dedicated on Cloud at Customer, you also get autonomous in the Cloud at Customer model, which can be smaller thanks to VM node subsetting and provides the same benefits to you on-premise with what an autonomous database can provide. What is really interesting if you look at autonomous is that you can see the technology which we essentially introduced with 23C a little bit in action already on autonomous, because autonomous is doing something similar. It does not use the same mechanism we have today with the automatic placement, which I presented, but it's working in a similar fashion. So there, if you are starting an autonomous database as a small database, we already started as a singleton, so only run it on a single node. And only if you increase the CPUs and we require more CPUs, we will scale out to a 2-node rack in the maximum. It's a little bit different on dedicated, because on dedicated, if you scale out, we will scale out to 2, 4, or 8 nodes, depending on the CPUs assigned. And please keep in mind that the I/O resource management is always based on the CPU. So how much I/O you get from the backend is really based on the CPUs you assign. So what RAC technologies are used within the co-managed database cloud service? Please remember that whatever you deploy in the Oracle Cloud, it's really a fully automatically configured real application cluster with everything. So all capabilities, what the RAC provides, like, is integrated into the virtual cloud network. Let it be the scan virtual IP addresses or the floating IP addresses for your host. So in OCI, the virtual IP addresses are called floating IPs, and this is fully supported. And what we will see later, we do support the use of additional application VIPs. What the co-managed database cloud service does not have out of the box today is we do not deploy them automatically with the database service, which is the requirement that you need to create them, which I will come to in the best practice part now. So let's look at the best practice parts. Before we dive into the services, let's look at the new capability which is going to be released soon on the Exadata Database Cloud Service. So while in the past you already can protect your applications, so not just the database with the real application cluster, but also an additional application on top of it, like Oracle Golden Gate, Siebel, or Apache, that had unfortunately to be done manually. So there was an OCI CLI command essentially to add that floating IP to the VCN layer, and you had to add the application VIP to the clusterware stack to get this. Now, what is new in the Exadata Cloud Service is that the VM cluster will soon be providing you with the capability to have a tab which is called virtual IP addresses. So the floating IP, instead of having to use an OCI CLI command today, can essentially be added via the UI or via a specific new OCI CLI command to the Exadata Cloud Service. So there you can create, add, and delete additional IP addresses, and that is creating and attaching the virtual IP addresses to the nodes, quite similar to creating a floating IP address on a compute instance. However, you still need to create the cluster-ware-dependent resources on the back end of the real application cluster, because there are multiple ways to create them. So there's either side up VIP CFG, there's SAV-CTL to add a VIP. So there are multiple possibilities, and there are also XA agents, which is creating the application VIP automatically for you. And since we do not know what you will be creating, we said we leave this up to the customer. One example how this can be working, you can see in this white paper linked here, Oracle Golden Gate microservices, where we essentially already have these screenshots in, which will be available soon. As I said before, you definitely want to create a database service when you are accessing in real application cluster. And it's not just for real application cluster. It's honestly, it's even for single instance databases that you do want to work with services, because the default service does not provide you with the load balancing capability. It does not provide you with application continuity. And it also does not provide you with capability of workload draining, which is quite interesting. So the workload, the load balancing part we have looked at before. So here you do see the CLB goal, which essentially is long for session or short if you want to use the runtime connection load balancing, which you can then decide to either be service time or throughput. You do find the capabilities for application continuity here to enable it if you're creating a service. And most importantly, you find the draining. And that is also important for the cloud services and on-premise, because whenever you need to do a rolling patching, that draining essentially dictates how much time your applications get to reconnect to another node, and that the application connection pool will be informed to essentially now fail over, and how much time existing sessions get to get off. So on Exadata, no matter on-premise or on cloud, if you have a planned maintenance with the drain timeout, you can dictate how long the node will wait that the sessions have time to fail over to the other node. However, there's a limit to that in the Exadata cloud service for infrastructure patching, so it will not wait indefinitely if you set the drain timeout too high. So the other thing you shouldn't use, except not using the default service, is do not define service names parameter in init Aura as well, or on the SP file. Really just use the clusterware resources to create your database service. By the way, the tools from Oracle, which is checking for best practices, Aura Check and Exa Check, will verify that additional services exist, and you really should be using them. If you are looking at the database cloud services, so first at the co-managed, the base database cloud service does not create any services out of the box. So there you always have to create a service. We made this on purpose because we do not have the service management in console yet. And as you want to have a service per PDB, and you will be creating multiple PDBs, hopefully, we do require that you are creating these services and using them. There's one trick you should be aware of, that a service can be defined with an additional domain. If you do not specify that, that will be defaulting to subnet VCN Oracle VCN.com, which sometimes isn't as good. If you are creating the service and you are giving your customer.com domain name to it, the service will have the customer domain name context to it, which is quite interesting to hide that you are running on in OCI. The same, by the way, goes for the Exadata base on dedicated or clouded customer, though there is a PDB service created for you, which is CDB_PDB. Though you can use the service, it's actually recommended that you do create additional ones for your applications. In Autonomous, you don't have to create these services. They are pre-created for you. A little bit depends on the type. So this is the output of Autonomous Dedicated, because you see it's TLS and the non-TLS services which do not exist in Autonomous Shared. And you also see that this is for Autonomous and not Autonomous Data Warehouse, because I have the typical OLTP service and the TP origin services. But I'm sure the most of you already know this, but this is really just using standard services. So if you're connecting to these services, then what I have found out, a lot of customers don't know that there's already the capability in Easy Connect to specify the advanced settings, which we formerly only had in the full descriptions. And what you see here with the connect timeout and transport connect timeout are really our best practices. We from the MIA team also have documented in the application failover best practice paper to essentially set when you are connecting to a real application cluster to ensure your application can seamlessly fail over to other nodes whenever required. If you're connecting to a base database cloud service or Exadata dedicated, one question I often gets asked is that the scan and the VIP DNS names are only resolvable within the virtual cloud network and not from outside. So what can be done about that if you do have a requirement to access these services from the public internet? My recommendation is always to use the connection manager, which also provides capability for your on-premise databases. Because with the connection manager, you can say which subnet has access to which pluggable database or to which service. So it's really on service level. So you can define that subnet A only has access to the service A running on PDB-A, and subnet B only has access to service B running on PDB-B. This is really, really complicated if you try to do similar things with multiple listeners, like a lot of customers has done this in the past. So the recommendation is really to use the connection manager for this, which makes it easier and which is also required if you come from outside. By the way, this technology in the similar way is used by Autonomous Share. So last but not least, if you have to deal with the host names, you do know that a real application cluster in Oracle OCI is always ending with oraclevcn.com. A lot of customers don't like that, though there's a really easy solution for this, which also makes the name resolution problem, which I've mentioned before when you're coming from on-premise, a lot easier, which is called private DNS. Private DNS can use DNS forwarding so that your on-premise host can easily resolve everything which is happening within the cloud, no matter how the redirection for your load balancing is working. There's a lot of good blog posts about this, so I will not go in detail. If you have any questions, feel free to reach out to the product management team. So all the capabilities we have seen, especially the real application cluster, are part of the Oracle Maximum Availability architecture, which is standardized reference architectures for deployments which are really up to zero downtime at all. So it does include real application cluster. It does include the client technology as of application continuity. It also adds data guard environments to this if you need a disaster recovery protection. And we do categorize these different different maximum availability levels. So either from bronze, which only includes backup, over silver, which includes RAC, to gold, which includes data guard, to really master application site, which have no downtime, even if you do upgrades or downgrades. And that is platinum with golden. Please have a look at the MIA website. You do find a lot of best practice white paper in there. And when the new 23C capabilities release, you will also find how you best set up your PDB consolidation with Exadata, for example, on these pages. Thank you for listening. I hope you enjoyed it, and have a good day. Bye.